Hey everybody, it's Ripley back again. Today we're going to talk about marginal functions in economics. Now, the most important thing probably that you need to take out of this entire lesson is that in economics, marginal equals derivative. They are the same thing, derivative. Okay, so let's say, for example, that I have a cost function. I'm going to let c of x equal to 0.0001 x cubed minus 0.08 x squared plus 40x plus 5,000. All right, now let's talk about what this thing really is. This guy right here is my cost function. Now what that means is if you give me an x, x is the independent variable, but in this case it represents the number of units being made, okay? Being made. Now, these are super simple models. So basically, we are manufacturing X boxes because there's an X there. Okay, anyway, and I want to manufacture 100 X boxes, and I want to figure out what the cost to do that would be. So I would simply go C of 100 is equal to 0.0001 times 100 cubed minus 0.08 times 100 squared plus 40 times 100 plus 5,000. And then poof, my calculator would spit out a number. I don't have my calculator out. I guess I could pop that. You know what? We don't need to do that. You can crank that through if you need to. But let's kind of look at this for a sec. What do you think? What do you think that 5,000 would represent? Well, notice that it never changes, irrespective of if I make 0 units or if I make 40 billion units. This guy right here, I'm going to try and make this thing go right again. It doesn't want to. This would represent my fixed cost. This would be my overhead. Okay? You're going to have to pay that regardless. That's rent, that's lights, utilities, et cetera, et cetera. All right. Now, let's talk about, just for a second, about what marginal cost would be. Okay? Marginal cost. Remember, marginal equals derivative. So what we're talking about here is c prime of x, which is pretty easy to take, right? 0.0003 x squared minus 0.16 x plus 40. Okay? Now, again, if I wanted to figure out the marginal cost at 100, it would be c prime of 100 is equal to 0.00. Good Lord, that's a lot of zeros, right? Times 100 squared, which is 10,000, minus 0.16 times 100, which is 16, plus 40. Whew, this is exhausting. All right, and out pops a number, whatever that number happens to be. But what does this represent? What does the marginal cost what is the marginal cost function supposed to represent? Well, if you think about it, it's the instantaneous rate of change or slope of tangent line of cost at a specific value. So let's say that I've got a cost function. This is x. This would be x units or x boxes, right? And then I've got a cost function. Now we think of cost as pretty much always going up, right? The more you make, the more it costs. So let's say that I've got some fixed costs here for producing 0 units, again, rent, light, labor, stuff like that, right? And then it's going to crawl up and do something like that, okay? But let's zoom in on this little chunk right here. This guy goes like that, right? If I take this little guy right here and zoom in on it. And let's say, just for giggles, that this value right here is my 100 from the previous problem. So down here sits 100. Now, what does that really represent? Ooh, look, now it turned into an arrow. Crazy. Okay, well, we know that c prime of x spits out derivatives of the c of x, right? And I can draw a line's tangent. So here's my line tangent. Nothing to it. But when we're talking about economics, what we want to know is, like, we want to know specific values at specific points. Like, we're not thinking as theoretically as we would as a pure mathematician. We want to know, okay, I'm making 100 units. I want to know what my marginal cost function tells me. Well, if you think about it, if I were to take this line and extend it over yonder just a little bit, and I were to move over to 101, now what this would represent, this guy right here, right? This line tangent, this is the slope. So C primed at 100 is equal to M, which represents rise over run. So if I move over 1 unit from 100 to 101, that's 1 unit, right? That's 1 more X box. Then what happens? Well, my cost goes from here to here, right there. Let's use a different color. Bam, red, right there. True? So M is going to equal some rise, which is really an approximate change in cost over 1 unit. So what it really tells me, what this marginal cost function tells me, is the approximate cost of making 1 additional, that's important. 2 words are really important in here. 1 additional unit more of 1, I should probably do 1 more additional unit. Now, the approximate cost of that would be C primed of 100. If I wanted to know the exact cost of making 1 more unit, if I wanted exact cost of 1 more unit, you probably can see how it would work, right? In other words, how much does the 101st unit cost? Well, that's pretty easy, isn't it? Since I know that C of 100 is the cost of making all 100 units, this would equal C of 101, which is the cost to make 101 units, minus C of 100. This is equal to the exact cost. Whoa, get out of there. This is equal to the exact cost of making the 101st unit. So this is cost of 101st unit. And we're set. However, we're lazy. We're mathematicians. We just need to be well, I guess we're economists. Economists. We want to be able to do this very, very quickly, right? We're doing business. We're like, all right, it's going to cost me about I don't know, $200 to make that 101st unit. Well, I'm going to sell these things for $400 or $450 or $500. So that means I'll make a profit of about $300, which is kind of interesting. Okay, now we've got marginal cost. We understand what it means, hopefully. Now let's talk about something called average cost, which is kind of cool. I don't like red. It makes me feel angry. All right, we're going to do, excuse me, let's go. We're going to do average cost of producing X units. Okay, now if you think about it, we know that C of X is the total cost of making X units. And what I want is I want the average cost. Now the way that a lot of textbooks will do this is they'll put a bar over this thing, which kind of makes sense, right? Because X bar is the mean. So this guy right here represents average cost. Now, if you think about it, how would you figure out the average cost of producing X units? You would take the total cost, and you would divide it by the number of units, right? Now you may say number of units. Well, you may say, well, wait a sec, Ripley, why don't we just divide it by the cost of the 100 or the 101st unit? Well, remember, our cost curves can change, right? I mean, you may have, here's your fixed cost, you may have a cost curve that does something like this. This guy may take off because of overtime, dealing with labor, dealing with, I don't know, maybe even having to rent a new facility. So you may get this huge dip in cost, right, at, I don't know, say X equals 50 units, right, for whatever reason. That's when you're like perfectly staffed and you can sell everything you make and you don't have to inventory anything. That's the sweet spot. But you want to grow. Well, if I want to grow, it's going to cost me a lot more money initially. Now, maybe somewhere up here I get another dip, woo, right, and I get to reduce costs. But I'm getting ahead of myself. Let's look at this guy. Average cost of producing X units is simply the total cost. Hey, look at that. We've got a function for that. Divided by the number of units produced, which is just X. Right? That's pretty easy. Not a whole lot to that. Now, I want to talk about the marginal average cost. So let's deal with all of our marginal average. My handwriting is awful right now. Cost, too much caffeine. All right, now whenever you see marginal, what does it mean? Take the derivative. So I know that the marginal average cost is simply C bar of, let's do a prime in here, of X. I think in text you'll see it where they take the C bar and they back it off a little bit. So they'll do this, like that. All right, and this equals marginal average cost. That's this guy. Which, if you think about it, now look, what do I have here? I've got a quotient, don't I? So I can either do a product or a quotient rule in this case, can't I? I could write this as C of X times 1 over X, in which case this guy's just C primed of X times 1 over X, derivative of the first times the second as it stands, plus the first as it stands, C of X, times the derivative of the second. Well, we've memorized the derivative of 1 over X, which is negative 1 over X squared. So if I want to clean this thing up, look at what happens. I get C primed of X over X minus C of X over X squared. And there's my marginal average cost, right? Derivative of the first times the second as it stands, plus the first times the derivative of the second. I just cleaned it up and made it pretty. Now, you don't have to memorize this because this derivative is relatively easy to take, but I just wanted to throw it at you. So now we've got marginal cost, we've got marginal average cost in an economic setting. And we want to make sure we do that, right? Because we're taking a business class, or excuse me, a business calculus class. Okay, I'll meet you back on the other page here in just a second, and we'll talk about demand functions and elasticity of demand and all that fun stuff. All right, you guys, let's go ahead and talk about this demand or price function, because it's going to be really useful in determining things like revenue and profit and things like that. So all the price function in our textbook, in most textbooks, you'll see this written as a lowercase p of x, which can be a little bit confusing because when we talk about profit, you'll see what that means. Or excuse me, you'll see that p becomes a capital P, and then we're like, what is going on with this? So don't panic, it's a lowercase x, or excuse me, a lowercase p. Now the way, let's say that I have a demand function that looks something like, I don't know, negative 0.02x plus 400. Now let me explain this really quickly. What it says is prices fluctuate depending on how many units we make. That happens because the more we make, the more are on the market. So you know, like scarcity of goods drives up the cost, which kind of makes sense. Less goods or more goods drives down the cost. And this function right here that I wrote, negative 0.02x plus 400, like if I only make one good, the price of that one good is going to be what? $399.98. But if I make 100 of these goods, right, then it's going to be what? $398. So that price is going to fluctuate based on how many goods I make. If I make 1,000, then I subtract 20, it's going to be 380. If I make 1,000,000, well, then I got to be really careful because I'm going to start losing money. Actually, the price would be negative. You'd have to give them away because you're saturating the market. Now, the reason this is important is because if we know the price of a function, and even if, excuse me, let's try again. If we know the price of a commodity, if we know the price of an item, then we can determine things like revenue. So if I do revenue, if you think about it, that's really easy. This is referred to as R of X, and it equals, think about it, revenue is the amount of money that comes into the company. So wouldn't that just be the price of the item times the number of items sold? This is typically written as X, P of X, right? If I want profit, now profit is this guy, profit, then this is capital P of X. You see what I'm saying? It can get a little confusing. Understand that this is the price function. This capital P is the profit function. Well, what's profit? How do we find profit? Isn't that just the amount of money coming in, or revenue, R of X, minus the amount of money going out, which is just C of X. So another way to write this is X, P of X, minus C of X, or revenue, money coming in, revenue, I can't spell today, minus cost. That's easy. That's easy. Nothing to it. Now, there's something else that shows up a lot in economics, and it talks about relative rate of change. So relative, I'm going to change colors. I need some blue in my life right now. I'm going to call this, relative rate of change or relative growth rate. You'll see this in the sciences as relative growth rate. So relative rate of change. This is pretty easy to find, and you probably heard about this in exponential growth and decay type problems. It's the rate of change relative to the amount that you had initially. All right, and the way that we write this is super simple. If we're talking about just a simple function, we know that f prime of x is the instantaneous rate of change, right? It's the derivative, it's the slope of the tangent line, blah, blah, blah. But if I want the relative rate of change, then I would write this as f prime of x divided by f of x. Sometimes you'll see this written, now think about this, it's the rate of change divided by the amount of the thing that you're talking about at some value of x. So let's do something like this. Notice I use an implies. If I do f primed of 2, right, divided by f of 2, what I'm saying is this is the instantaneous rate of change of f at 2 divided by the amount that is there at 2. So if I want the relative rate of change of revenue, it would just be something like r primed of x divided by r of x, and then I plug in my x value. Remember, x represents the number of items that are created. This would give me the relative growth or decline rate in revenue for a specific number of items created. Okay? If you want to write this guy as a percentage, then yeah, it's pretty easy, right? You just do this divided by f of x times 100%. But we're smart enough to figure out the decimals and percentages and all that good stuff. Okay? All right, let's talk about one more topic and then we are done. Let's go back. Let's go dark blue. I'm feeling a little colorful today. We're going to talk about elasticity of demand. And elasticity, that does not, elasticity, sorry, of demand. What this really means is remember, demand function is the same as price. And one of the things that you want to do when you're in business and you're selling a commodity or you're selling an item, you want to find what's called a price point. The price point is the point at which if you jigger that price at all, you lose money for some reason. Either your revenue goes down or your cost goes up, something like that. So one of the main aspects of economics, the economic sciences, is, hey, how do we determine a price point? And the way that we do that is using what's called elasticity of demand. Now, we can get super wonky in terms of how this is created. I don't want to get into too much theory on this. I'm going to give you the formula, and then I'm going to tell you how it's used, because I think that's far more interesting. I think it's far more applicable too. If you want to get into the theory, it's, jump on Wikipedia and check it out, see how it works out. Or we can meet in class so we can discuss how it's made. Okay, elasticity of demand is written like E of P is equal to negative P F primed of P divided by f of p. Now let's take a gander at this here for just a second. Now, first and foremost, elasticity is a function of p. It's a function of price. So let's look over here. I know that p of x, this is the price as a function of the number of items made, right? That gives me this negative 0.02x plus 400, right? However, this is e of p, so I'm going to have to take the inverse of this guy. Let's do that right now, just for giggles, because this says I need to plug p's in, so I need to plug p's in. So if I started with p of x equals negative 0.02x plus 400, right? Isn't this going to turn it? Let's see if I can do this in my head. I subtract the 400 divided through by the negative 0.02, so I get what? X of p, which we'll call that f of p when we're done, is equal to, excuse me, is equal to what? Negative 50p, I think, plus 20,000, isn't it? Plus 20,000, yeah, divided by 2, yeah, 20,000. I'll buy that. So we're good. All right, now let's look at what this means. What it says is you hand me a price that I want to sell a commodity at. I stick it in here and it tells me how many of those things I should make. So you can kind of see where this price point idea comes from, right? It's like, well, I want to figure out the perfect price where I can make the perfect number so I can maximize things like profit and revenue. Okay, anyway. Now, again, we're not going to wonk out on this, but you can see that f prime of p divided by f of p is actually a relative rate of change of f of p, or f of the price, okay? But don't worry about that. Let's just fire this thing up. We're going to do e of p is equal to negative, respect thy negative, please, p, so that thing's not going to change, right? And then f primed of p, oh, this, I'm getting a little ahead of myself, aren't I? I've got this is equal to f of p, that's this guy right here, which implies f primed of p is equal to, it should be relatively easy to see that this is negative 50. So I'm going to go negative p times negative 50 divided by f of p, which is what? Which is negative 50p plus 20,000, right? Now, let's make this a little prettier, right? Those negatives are going to cancel and make a positive. Let's divide through by 50, and I end up with p over, what is that, 400? 400 minus p. So that's e of p. That's what I've got, okay? Now, let's say that I want to make, I'm going to find something like, I don't know, I want to, let's say that this price point is for Xboxes, right? Not Xboxes, that'd be too expensive. Nintendos, the little guys, you know, that have all the old games on it. And I'm trying to figure out a price point on this. So what I do is I'm going to go, let's say I want to charge $100 for one of those little Nintendo thingies, you know, the ones that were really popular back at Christmas. Well, I would simply go, let's see, 100, plug it in, right? Because I've got this elasticity of demand function. Ooh, I'm going to sneeze. Ooh, excuse me. Divided by 400 minus 100, which is 300, and poof, out pops a third. Now you may say to yourself, Ricky, what does that tell me? I don't even know what that means. Well, it's actually quite simple, okay? There's going to be 3 different cases, and you're going to want to write these down, but there's going to be 3 different cases. You're going to have e of p is greater than 1, e of p is less than 1, and e of p is equal to 1. Okay? I'm going to change my color so we know exactly what we're talking about here. Now let me explain what all 3 of these situations tells us. If e of p is greater than 1, then this implies that our price is elastic. Okay? Now, you ready? Because this can get a little bit crazy. If the price is elastic, an increase in p implies a decrease in revenue. I'm going to go R of X. Okay? A decrease in p, in the price of the commodity, implies an increase in revenue. So, raise prices, revenue drops. Don't raise prices. Decrease prices, revenue goes up. Might want to drop our prices. Okay? If e of p is less than 1, then this implies inelastic. Your price is inelastic, which kind of sounds like a bad thing, but it's not about good or bad. It's just telling you what to do with your price. So what this means is if I've got if I raise my price a little bit, you don't want to do huge price increases because these curves can be crazy looking. You're talking about incremental price increases relative to how much it costs. So if you're talking about my in this case, the Nintendo, I'm going to drop it $1. I'm going to drop it $2. I'm going to drop, I'm not going to drop it $40 or something like that. If it's inelastic, if I raise the price, then I raise revenues. If I lower the price, then I decrease revenues. That's bad. Don't lower your price. You need to raise the price. Now, if it equals 1, that's the sweet spot. Guess what? This is called unitary. And that is the sweet spot. Guess what? You have your price point. Don't touch your price. If you raise your price, you're going to lose revenue. If you lower your price, you're going to lose revenue. So, what's the moral of the story? Don't freaking touch the price. You found your price point. So that's what elasticity of demand is all about, which can get really confusing because of that word, which is sitting here as well. What it should be called is elasticity of price. They use that word, elasticity, because it means like how much wiggle room do we have in the price of this commodity? And of course, you got to remember that this whole section deals with very, very simple economic situations. Like, I'm selling beads like bead necklaces on a beach. You don't have any competition, you don't have any real inventory, anything like that. Macroeconomic factors, that's where things get a little crazy. We're talking about super, super microeconomic issues in this case. Because when you talk about macro, you got a lot more going on. All right, thanks for listening to me. Hope you enjoyed, and I'll see you in class tomorrow. Have a good day.